In this video, I'm going to take apart this 2.5 liter non-turbo engine out of this 2013 Subaru Legacy, and I'm going to be replacing the failing head gaskets, and in the process I'll show you how I resurface the block and cylinder heads at home, and I'll also adjust the valves while I'm at it. Alright, welcome back to the channel. I am working on this Subaru 2.5 liter non-turbo engine. It came out of this 2013 Subaru Legacy, and it has a bad head gasket. The symptoms are that it's overheating, it's losing coolant. So I do have a video on how I remove this engine. I'll leave a link in the description below. And right now I'm just going through all of the electrical connectors and all of the hoses. I'll be unplugging those as I try to remove this intake manifold. The intake manifold itself is held on by 4 bolts on each side. These bolts also hold these metal brackets in place. Once the brackets are out, I'm just going through and disconnecting all the hoses. There is a metal EGR pipe that I'm using this adjustable wrench to loosen up the nut. As always, my trusty heat gun comes in handy to remove these hoses. So now that I have everything pretty much disconnected, there's just this one PVC hose on the bottom. There is a clip that you can use a flathead screwdriver to undo. As I'm lifting it out, there are several more connectors underneath the intake manifold that I have to take out. Once that's done, I can lift the intake manifold and continue on with the process. So next on my list is the flex plate. Now you don't normally have to do this. I removed it so that I can go ahead and get access to the rear main seal. I'm planning to remove and replace the seal while I'm at this. So that's why it's got to come out. Timing cover is next, followed by all of the timing components. I'm removing the alternator and the bracket just to make things cleaner and easier to see, but you don't normally have to do this if you're doing it on your own. Before I proceed with removing all the timing components, I'm going to, well, obviously first of all remove the plugs so that I can rotate the crankshaft easier, and then I'll rotate the crankshaft clockwise, get all the timing marks lined up, and at 12 o'clock there's a mark on the crankshaft sprocket, and then there are marks on the camshafts. So what I'm going to do is mark both the timing belt and the camshaft pulleys, just in case if you are doing this job and you want to reuse the timing belt, this will allow you to reinstall it in the correct position. What I plan to do is install the aisin timing belt kit, and the timing belt on that kit is awesome. It has all of the timing marks already painted, so it's just a matter of lining up the timing marks on the camshaft pulleys, and that's it. There's no guessing, no measuring. It's pretty foolproof. Now I'm going to take off the valve cover, followed by the cylinder head bolts. Now I know there's a lot of discussion out there on whether you can reuse these bolts or not. So just to play it safe, I bought a new set of bolts and we'll be installing them throwing these out. And when I do this job, I also like to remove the coolant crossover pipe and replace the 2 O-rings and clean up the gasket surfaces. So what I'm doing now is what I like to call the preparation stage, and this is the most tedious and time-consuming part of this whole job. I'm going through and I am cleaning up and resurfacing all of the gasket surfaces. I'll also be resurfacing the cylinder head and the block here at home. But before I can do that, I need to get everything out of the way, and that includes these dowel pins. I found that the best method to remove them is to use a 1/4 inch 9mm socket. It fits just right inside, and then just use some channel lock pliers to take that dowel pin out. Great, so now that everything is out of the way, I can go ahead and resurface this block. I will show you how to build this setup later on in the video, but what I do is I take a glass with a piece of sandpaper glued on the bottom of it. I place a weight on top, and then I just go back and forth, pulling and pushing several passes and cleaning up the cylinder block in between. And this sanding results in a nice, clean, even surface. What I like to do is the majority of the passes will be done with 150 grit, then followed up by a couple of passes with 220, and then finishing off with 320 grit. You don't want to go above 320 because if you make the surface too shiny, too smooth, then the head gasket will have trouble sealing. I finished one side of the block, and then I'm going to move on to the other side. So once the sanding phase is complete, I'm going to take my straight edge and a feeler gauge and then check the block for flatness. This is important to do because you want a nice, flat, even surface, and the same process has to be done for the cylinder head. So now that the cylinder block is ready to go, it's time to move on to the cylinder heads. And here is how I build this resurfacing rig, if you want to call it. And I'm not the first person to do this, but first you want to start out with a nice flat surface, and usually a piece of glass is the best thing for this. In my case, I had a mirror, an old mirror lying around. I then used some 3M spray adhesive to glue 2 sheets of 150 grit sandpaper, and then follow that up with some kind of liquid. You want to have a liquid on the paper in order to help with the sanding process. In my case, I use WD-40, and then I do a few passes with 150 grit glued down. I clean the sandpaper in between. Once those several passes with 150 grit are done, I then rip out that sandpaper and I glue a couple of sheets of 220, do another set of passes, and then I glue a sheet of 320 as my finish stage. So here's what the cylinder head looks like after several passes with 150 grit sandpaper. After a couple of more passes with 220 and 320, this will look brand new. One of the cylinder heads does have a plastic thing in the way that's preventing the full range of motion, so that one's going to take a little bit longer to do. Alright, so now I'm going to reinstall the dowel pins, and this is just a personal preference of mine, but I like to clean everything up with some brake cleaner. I spray the cylinder bolt holes, and then I spray the cylinders themselves to wash out any debris, anything else that does not belong. I then use my air gun to spray everything out, get everything nice and dry, and then finally I follow that up by spreading a thin coat of oil on the cylinder walls. I will be reinstalling this block right away, so oil is acceptable to use, but if you know that it's going to be a while before the engine block is going to get reinstalled, you'll want to use some assembly lube instead. Alright, this is the final cleanup of the surfaces before I reinstall the head gasket. Here's a quick shot of the cylinder heads after they've gone through the resurfacing process. Next up, I'm going to install the new OEM MLS gasket. And just a heads up, I will have a list of part numbers and everything else that you're going to need for this job in the description. So now I'm going to install the cylinder head bolts, and I did buy a brand new set. These are the new updated black version, I guess. They come with these new updated instructions. You'll want to coat the bolts and the washers in oil, and there are multiple steps to tightening up all the bolts, and here they are. Great, so I've got both sets of the cylinder heads installed. I'm going to move on to putting everything else back together, and before I do that, I always like to run a tap through all the bolt holes. I also clean up all the bolts themselves, and it just makes for a hassle-free reinstallations. I've had some bad luck in the past with threads stripping, so I always like to clean them up beforehand. So like I said in the beginning of the video, I used an aisin timing belt kit, and I think in my opinion it's one of the best kits out there for this engine. It uses all the same manufacturers that Subaru uses for their parts, and the best thing is the timing belt. It has timing marks already painted on it, so all you have to do is line up those marks with the marks on the camshaft and the crankshaft sprocket, and you're good to go. There's no counting of teeth, and it's pretty hard to mess this up. You can notice that one of the pulleys I left off, and that's that orange pulley. Once the timing belt is in place, that's when you want to install that orange pulley last. So one of the recommended things to do is to have your valves checked and adjusted if needed. I'm not going to go too much in depth on the whole process of adjusting the valves. There are plenty of videos out there to show you how to do that. But basically it involves using a feeler gauge and checking to see if you have the proper clearance, which is 0.20 millimeters for the intake valves and 0.25 for the exhaust. If something is out of clearance, you loosen up the adjusting nut and then slightly turn the adjusting screw counterclockwise if you want to loosen it up, and clockwise if you want to tighten up the clearance. So when you have the clearance that you want, just retighten the adjusting nut and you should be good to go. Typically I found that the intake valves are on the loose side, so they're going to need that adjusting screw turned clockwise. And then the exhaust valves, they're a little bit on the tight side, so they need to be loosened up a little. So as I'm doing each valve, I'm looking for the feeler gauge to have a slight bit of drag. That's when I know that the clearance is in spec. So this process is done for each cylinder one at a time. You want to have the cylinder that you're working on at top dead center. That's going to relieve the tension on the valves. And once you're done with that cylinder, you just rotate the crankshaft 90 degrees. And then you move on to the next cylinder. And then once you're done with that, rotate it another 90 degrees. And then finally another 90 degrees for the last cylinder. Alright, so if you can remember in the beginning of the video, I took off the flex plate because I plan to replace this rear main seal. And to get this out, the easiest way I found is to drill a hole in between that seal and then drive a screw. And then use some kind of a pry bar and a block of wood to pry on that screw, and that will pull the whole seal right out without any issues. And then it's just a matter of driving the new seal in place. Now that I have the seal in place, I'm going to reinstall the flex plate. The bolts do require a certain torque and then a certain angle when tightening them up. So that's why I like to draw marks on all the bolts and then tighten to the required angle. So one little tip that I found is helpful to hold the crankshaft in place so you can tighten these bolts is to insert a socket into this place right here. So the socket will hold the flex plate and keep it from moving so that you can tighten those bolts. And then you can use the same process with that socket to hold the crankshaft in place when you're tightening the crankshaft pulley in the front. So that's it. The engine is ready to be reinstalled. I'm not going to go into much detail on the reinstallation process. You can use the link that I have below in the description to look at the full in-depth video of how I remove the engine, and then just follow that process in the reverse order. So I've got everything pretty much back together. I did want to go over one step that I like to personally do myself, and that's when, before running the engine for the first time, I like to fill it up with some inexpensive oil and install an inexpensive oil filter. I then run the engine for a few minutes, shut it down, drain that oil and remove that oil filter. And the thought behind that is any contaminants that may be in the engine that have made their way into the engine will get removed. After that first fill and drain, I then fill up with good quality oil and install a good quality oil filter. Now, before the first engine startup, you can see I took out the fuel pump fuse, and then I'm cranking that engine until that oil pressure light goes off. There you go, it went off. So now I can go ahead and reinstall that fuse and start the engine up. This whole process ensures that there is adequate oil pressure before the initial startup. After a few minutes of idling, I like to increase the RPMs on the engine, get it up to temperature, get the coolant circulating throughout the whole engine, and at that point I will shut it down and then perform a burping process on the cooling system. And that just involves removing any air from the cooling system. To do that, you have to buy this tool. It's a coolant filling funnel kit. I bought this from AutoZone for I believe $40. It attaches to your radiator using these adapters, and then the funnel is placed at the highest point of the cooling system. Then you fill the funnel up about a third, maybe a fourth of the way, and then you just let the engine run. So during this process, when the engine is running, all of the air bubbles will start escaping, and this will ensure that the cooling system has no air in it and will operate optimally. Again, the key is to let the engine warm up so that the thermostat opens up and the coolant is circulating through the whole engine. Most of the air is usually trapped in the heater core, and this tool just makes it so much easier to get that trapped air out of the coolant system. Alright, so that's going to do it for this video. This was a long one, and I hope you guys found it helpful. I will try to leave all of the torque values for all the fasteners in the description below, along with any relevant links. So until next time, see you guys.